we're looking at programming the MR1 robot, and we're now looking at the ultrasonic sensor. Now the ultrasonic sensor basically works by sending out a pulse. The pulse is started by sending out a pulse from your controller. In this case, there's a little chip over on the left in this diagram. The start pulse then gets the sensor to send out a chirp, a high frequency chirp that you cannot hear. That chirp generates an echo off an object which comes back into the sensor, which then implements an echo time pulse, which is then taken back by your processor and measured the time difference, and then you can use some sort of mathematical equation to convert that into a number of centimeters away. So that's basically how this works. Basically, the ultrasonic sensor that I use is the HCSR04, and it has this footprint that actually allows it to fit nicely into the MR1 very snugly. In fact, you don't even need glue, it just sits in and holds it in very nicely. And basically I buy mine from Little Bird Electronics, which is an Australian seller, and that costs you $3.56 Australian, and that can be bought from this particular link here. You can also type in HCSR04 into eBay and you'll get them for about the same price or a bit cheaper from China, but it does take a lot longer to come. Basically, this is the context of the entire circuit for the robot that we're actually designing here for the MR1, and you can see there that the ultrasonic sensor is symboled by those two round circles on the board, which match the diagram down the bottom. If I take that out of context now and remove all of the other wires, this is what we're looking at. So there are 4 wires, are red for 5 volts on the left. The trigger signal is, I use a yellow. The echo signal I use an orange, and the ground I use a black, and I always try and plug it in this way. I usually try and use ports 8 and 9 on my Genuino 101. That's so that I can always remember port 8 is the port 9, 8 sorry, is the trigger, and port 7 is the echo. It's important to remember those two things there. The pros and cons of using this particular sensor. The biggest pro is it's cheap. That's mainly why I use it. It's also quite easy to implement. You don't actually require any special downloaded software into your Arduino or your Genuino. And it's got a reasonable range. So it works from a pretty reasonable distance. So it's pretty good for a whole heap of applications. You could actually use it as a car park sensor, just like the ones that work in modern day shopping centres where it tells you whether a car's parked there with a red or green light. One of the cons though is that it actually requires you to do the processing rather than it doing the processing, so it has no real ability to give you a distance itself, so therefore your program has to stop and wait for the sensor to do its thing, which if it senses off into infinity has to have a timeout for you. So basically you can actually have a whole issue with it slowing your processing down if you have too many of them, or if you're doing other processing at the same time. Now before we get into the actual programming, there's a few programming concepts that we need to sort of understand in order to be able to program our robot. The first concept basically is to think about error conditions that might be caused by our ultrasonic sensor. Our ultrasonic sensor is not perfect, and in fact we've got this from the data sheet here. It actually has a range of 2 centimeters to 400 centimeters, and that's in an ideal world. The reality is that it won't be quite that good. It also says that it's got an accuracy of 3 millimeters. I severely doubt that for a $4 chip. You think it would be actually a bit less accurate than that. But anyway, basically we're going to need to set a maximum reading and a minimum reading, and if it's outside of that, we'll actually give a -1 value or an out of range value, so that we don't actually have any error conditions running in our program. It's always a good idea to do this sort of thing with any sensor, but we'll do it specifically here. The next programming concept we have a look at is serial. Now, the Arduino or Genuino 101 has the ability to give back information to the computer when it is connected by the programming USB cable. It sends it back to something called the serial monitor, which I'll demonstrate later. But this is a really good idea for diagnostics, and we'll be using it a lot in this particular part of the program. We also have the reference there so that you can actually see where I got that from on the Arduino website. The next concept is looking at our delay. Now, I've showed you in an earlier video the delay using milliseconds. We need to use the delay in microseconds, so we need to explicitly say delay in microseconds for that. And the reason why we'll be doing that is because our sensor needs a very short pulse of a number of microseconds in order to actually activate. Just so you're aware, there are 1,000 microseconds in a millisecond, and there are 1,000,000 microseconds in a whole second. The web URL for that piece of information is available there. We now have the idea of the pulse in, and what the pulse in does is it starts reading the pulse when it goes to high. It will continue to read it while it is high, and it will return the number of milliseconds that pulse was high as soon as it goes low. So that's how the ultrasonic sensor works. It sends out the pulse, and when it receives the echo back, it actually has that pulse time come back. So we'll be using the pulse in function in order to make our robot give a reading in time. The reference for that is available just there. The final programming concept that we need to look at is global versus local variables. And you can see there that we've got a bit of code that we've already written, and I've added in an extra line or two of code. But up at the top, red light and white light are global variables. They've been created on the main line, so they are global variables. Down in the setup function, there is an int a variable equals 15. That is a local variable, and you'll notice that down in the loop function, I put the fact that the a variable will not work in that setup. A variable is a local variable. It only works in the function it was created, and that function there, where it says void setup and the curly bracket, down to where the curly bracket closes, is a single function, and that's the only place a variable will work. Whereas because I've created red light and white light on the main line, it will work everywhere. So we're starting off with the code that we left off for the LED light on the MR1, and basically we're going to first start by setting up our serial output so that we can do some diagnostics. So basically what we're going to do is in this section here, we're going to begin our serial. Now with the Arduino 101 or the Genuino 101, we need to actually add this line, while not serial, and then do that. That means that it's just going to wait for the serial to actually begin before it actually starts doing the next bit of code. Otherwise, it'll actually try and start the serial terminal off and cause errors. So basically, we're now going to type in serial dot begin, and we're going to set our rate to 9600, which is a fairly standard rate of the speed of our serial connection. So basically that's to start it off. The next thing we need to do is to actually write something to it. So basically we do this serial dot print ln for print line, and in brackets in string I'm going to put initializing, because that's what we're doing right here. We're initializing our Arduino 101. So basically this should work. Now basically at the moment I've got my serial monitor and it's sitting there pumping out -1s from the previous program that was ending. And you can see there that that's the full setup. I just might bring that in so it's going to be that size. I'll just put this down here for the time being so I can get it again. And going back to there, you can get it from this. So serial monitor here, to turn it on. Now if I actually have that running, if I press the upload to the script, and you can see there it's just waiting, and there it goes, and we're waiting, and there you go. So it just says initializing there, and I just noticed that the lights came on in the robot exactly as it said initializing. So we could actually put some more debugging in here. So basically we can go, this will be over the top, but we'll do it anyway. Serial.println red lights on, and let's put a delay in here just so that we can see this happen we'll just go 500 milliseconds just so it doesn't take too long, and then we'll actually copy and paste this line here, Control C, Command V, and we'll put this white lights on, and I should probably put a space there and space there, and I probably should put a delay in here as well, Command C, just so that we can see this happen, Command V. So let's actually upload that and see what happens. So we're uploading it now. We're going to wait for 5 seconds because it can take a while, and we should see some stuff come up on the screen. Red lights on. So you can see it says initializing, red lights on, white lights on. So you can see that we've got an initialization sequence happening there, and that is basically good for our use of our serial. Now that we've got our serial working, it's now time to start setting up for our HCSR04, and basically the ultrasonic sensor is a little bit complicated, but it makes it easier if you actually break it down into small chunks and do them one at a time. So all the chunks, I'll actually give you a highlight of what they are. First of all, we've got to set up the HCSR04 variables, and that happens up here. We then need to initialize the HCSR04 pins on the 101, and that'll happen just there. And once we've done that, we need to go into the main loop, which is this one here, which will happen repeatedly. And we need to basically do a number of steps in order to take a reading. The first step will be to ensure that the trigger is ready. The second step will be to send out a pulse. That's a pulse of ultrasonic sound, which we can't hear. The third will be to measure the echo pulse. That's the pulse that comes back when we echo it. The third thing will be to limit the distance to a given range, because we don't want nonsense variables. And the final thing will be to send to the monitor so that we know we've got a reading. So we're going to send it to the serial monitor, which for the Arduino 101 or the Genuino 101 presents a few minor glitchy problems, which I'm hoping that I'll fix soon. But basically we can get around those pretty simply. So let's go back up to the variables now. And the first variable we're going to create is our distance variable and our duration variable. And the distance and duration variables are going to be long numbers, which means that they can hold decimal places, otherwise known as a float in other programming languages. So we've got duration, and the duration is the length of the pulse, and the distance is the length roughly in centimeters of how far away the object that is detected is. We're going to set up an integer, which is going to be called trig for trigger, and we'll set that equal to 0, because that's going to be on pin 0. In my diagram I had it on different pins, but I had a few problems earlier on, so I'm testing it on pin 0 and pin 1. We may be able to change that later. We've got the next one is we've got echo, and the echo will also equal 1, so trigger is on pin 0 and echo is on pin 1, so you'll have to wire yours up accordingly, or you could change to the numbers that you're actually using. Basically, my maximum distance that I'm going to allow my reading to have is going to be equal to 300, and we can play around with these readings. So 3 meters away basically, and my minimum distance, we'll notice that the minimum distance according to the documentation is 2 centimeters, so let's go 5 centimeters, and that should be the minimum distance we can be away from an object before we check it or test it. So that's the variables set up, and those are all the variables we're going to use in order to do this. So now we need to set up our pins, and that's just simply pin mode for the trigger. The trigger is an output pin, and we're going to say pin mode for, oops, I didn't say that right. If you don't spell it right, it doesn't go orange. So echo, and that will be an input pin. So the echo receives an input, and that way we've got that reading there. So now we need to go through and ensure that our trigger is ready, which is in our loop. So we'll tab across here, and what we do to do that is we're going to set our digital right on our trigger, and we're going to make sure it's low, and we're going to hold it low for a delay in microseconds. That should turn orange of 2. So a delay of 2 microseconds, which is a really short period of time, and that will make sure that the trigger is ready to fire when we set it up. So basically we're going to send out a pulse now. The pulse is going to be a high, so digital right, and we're going to set the trigger to high. Good idea to be consistent with the spacing, so I'll just put a space up there too. And then we're going to have a delay, so we're going to have the pulse go for a period of time, and once again it's going to be in microseconds, and it's going to be for 10 microseconds, which is what the data sheet says. And once that's done, we're going to set the digital right of the trigger pin back to low, so it's going to turn itself off again, and that should basically set that up nicely. That will actually cause the echo pulse to go high for a duration, and the duration, which is a variable that we created above, is going to be equal to the pulse in reading of the echo pin, and we're going to be reading high. So while it's high, it's going to read that and store that number in microseconds in the duration. Next thing we're going to do, whoa, I missed a step here. We're actually going to calculate the distance into centimeters. So basically, the way you do that is you say distance is going to be equal to the duration divided by a magic number called 58.2, and you should take all that information to a physics teacher and ask them why that number is 52. Basically that's just a number that I've been told, but I do know it has something to do with the speed of sound in air and the distance that it's going to travel, and I could sit down and figure it out for you, but there's no point knowing that. We just need to know that number 58.2 is a good number. So basically we're now there to limit the distance to within a range. So if the distance is going to be, oops, I'm going to spell it right, is going to be, if the distance is going to be less than the minimum distance, okay, or, which is 2 pipes, the distance is going to be greater than the max distance, then we're going to make the distance give an error number, and the distance will be equal to -1, which just tells us that there's the reading has gone too far. So basically I've got that there. There's an extra bracket there that I don't want. So that's going to be there. Then we send that to the monitor with a serial.print ln, and let's just send that distance in. Not inverted commas, distance. The variable should just read the number out. So let's just upload that to our robot now, and you'll see that I'll get an error. There, opening serial port. This is the problem I'm having. The serial monitor should open, and it opens, but not very well. Tools, serial monitor, there it goes, initializing. Now it's now reading the distance. I've got my hand in front of it there. I'm moving my hand back. Hand's not a good thing to read. Let's read the wall over here. So looking at the wall now, the wall's a nice shiny piece of stone, so it should reflect the sound nicely. My hand isn't so good. I'm moving it closer now. It's getting closer. It's reading 10, 9, 8, 7, 6, 5, and goes -1 because it's too close. So that's good. And now I'm also going to point it across the other side of the room now, just maneuvering it around. You can't see me doing this, but the other side of the room is about 2.4 meters away, which is correct. So that's pretty good. And you can see that my hand's in front of it now. It's giving all sorts of weird readings, but we should be able to do something with that as our robot's driving along. See how it's reading -1 there? That's because I put my arm in front of it, and my arm is at an angle, and my arm is covered with soft material. So this sensor has got limitations like that, but basically we need to be aware of that. The next thing we're going to be aware of, I'll just close this off, is that it actually has a sound that it makes, and that sound we can't hear, but if I hold my phone up to it and try and video it, it saturates the microphone of my phone, and basically you can hear that saturation. So I'll demonstrate that to you now. And there's a bit of an observation we can make about that. So that bit of video there, you notice that as the phone actually came into very close to the sensor, that the sensor actually got higher with the noise it's making. That's because the closer things are, the quicker it is to read, and the further away things are, the slower it is to read. So that's a limitation that you need to be aware of when you're doing the ultrasonic sensor. But that basically concludes this very long video that I've made that will help you to be able to program the ultrasonic sensor, the HCSR04, on your Genuino or Arduino 101.